Looking at section P.7, part 2, starting by equations involving absolute value, says the absolute value of x describes the distance of x from 0 on a number line. To solve an absolute value equation, we rewrite the absolute value equation without absolute value bars. It says if c is a positive real number and u represents an algebraic expression, then the absolute value of u equals c is equivalent to u is equal to positive c or u is equal to negative c. Now, if we're talking about distance on a number line, distance from 0, if I am c units away, I can be at positive c, but if I go c units away in the opposite direction, I'm at negative c. So when you're looking to figure out what is the value of, in this case, u, you are looking for two possibilities. It is going to be equal to positive c or it's going to be equal to negative c to find out all the possible values that when you take the absolute value, you get that value of what they're calling c. So let's take a look. So solving an equation involving absolute value. It says to solve 4 times the absolute value of 1 minus 2x minus 20 is equal to 0. Now our goal is to figure out what is going to be inside of these absolute value bars. We need to isolate our absolute value bars first. That means everything from the outside has to go away. What do I get rid of first? The 4 or the 20? Well, just like any equation, you undo the addition or subtraction part before you undo a multiplication or division. So in this case, we're going to start by getting rid of that minus 20 by adding 20 to both sides of the equal sign. We're left with 4 times the absolute value of 1 minus 2x is equal to 20. And then I still need to get rid of that 4 before I can try to break my absolute value into my two problems, my one positive, one negative. So we can do that by dividing by 4 to both sides. And now that I have the absolute value of 1 minus 2x is equal to 5, a great way to remember absolute value is there are 2 bars. So if we have 2 bars, we're going to end up with 2 problems. Now, before I break them into 2 problems, every time I teach this Algebra 1 wise, I refer to my bars as brick walls. Nothing goes in and nothing comes out. The only way to get rid of those absolute value bars is to break them down. And before you can break anything down, you always have to check your surroundings. I get rid of everything from the outside. So that's what we already did. We took care of all the stuff on the outside, and now we're ready to 2 bars. 2 problems. One is going to be equal to the positive version of that, and one's going to be equal to the negative. So I'm going to write 1 minus 2x is equal to my positive 5, and 1 minus 2x is equal to my negative 5. Whatever is inside of these absolute value bars, that's either going to end up being a positive 5, or it's going to end up being a negative 5, that when I take that absolute value, I get an answer of positive 5. So I have my 2 equations. Let's go ahead and solve them down. Subtract 1, negative 2x is equal to 4, dividing by negative 2, x is equal to negative 2. Other equation, subtracting 1, negative 2x is equal to negative 6. We get some nice answers here. X is equal to positive 3. So the 2 answers I ended up with are, the solution set is negative 2, comma, positive 3. And just like any equation, you can take and plug those answers back in and solve it out and make sure that they work. The next type is looking at quadratic equations. Now, a quadratic equation in X is an equation that can be written in the general form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers, as long as a is not equal to 0. If a was equal to 0, that means that whole first piece would be equal to 0, which would then make it linear. That's why they state that a cannot be equal to 0. A quadratic equation in X is also called a second-degree polynomial equation. We already talked about degrees in our polynomials. It says the zero product principle. Zero product multiplying. If I multiply anything by 0, we end up with the answer 0. It says to solve a quadratic equation by factoring, we apply the zero product principle, which states that if the product of 2 algebraic expressions is 0, then at least one of those factors is equal to 0. So they say if you have a times b is equal to 0, that means a is equal to 0 or b is equal to 0. So going about solving a quadratic equation by factoring, part 1 says, if necessary, rewrite the equation in the general form ax squared plus bx plus c is equal to 0. moving all non-zero terms to one side, thereby obtaining 0 on the other side. Step 2, factor, right? What multiplies to make C and the A, that breaks down to add to make the B value or subtract, whichever operation you end up with. Step 3 says to apply the zero product principle, setting each factor containing a variable equal to 0, just like we did with those ugly fractions when we had to take and break them down into our factors. We set each of those pieces equal to 0 to find the exclusions from the denominator. You're doing the same thing here. You're just trying to figure out what x would equal to solve out that equation this time. So step 4, solve the equations in step 3, and then check the solutions in the original equation. You always want to make sure that they work. All right, let's try an example. We have 2x squared plus x is equal to 1, and they want us to solve by factoring. So step 1, move all non-zero terms to one side and obtain 0 on the other. Get everything together on one side, the equal sign. That means we are going to move that 1 over. That's going to end up giving us a 2x squared plus x minus 1 is equal to 0. Step 2, they want us to factor. So we have a 2x squared and we have a 1. The only way to make a 2x squared is an x times x. The only way to make 1 is 1 times 1. And we are subtracting to make a positive 1x. So that means my 2x times 1 has to be the positive to give me 2x, and my x times 1 has to be the subtraction. Right? When in doubt, FOIL it out to make sure that it works. Right? Outside terms, positive 2x. Inside terms, minus 1x. That leaves us with a positive 1x. Now, it says in steps 3 and 4, set each factor equal to 0 and solve the resulting equation. We have two numbers or two expressions that are multiplying to make 0. That means 2x minus 1 has to equal 0, or x plus 1 has to equal 0. And solve them both down. Add 1. I'd have 2x is equal to 1. Dividing by 2, I have x is equal to 1/2. Subtracting 1, I have x is equal to negative 1. And then they want us to double check it. If I were to take and plug in a 1/2, I would have 2 times 1/2 squared plus 1/2. Is that equal to 1? Well, 1/2 squared is 1/4. 1/4 times 2 is a half. A half plus a half is equal to 1. Yep, that works. If I plug in a negative 1, 2 times a negative 1 squared plus a negative 1, is that equal to 1? Excuse me. Negative 1 squared is a positive 1. 1 times 2 is 2. 2 added with a negative 1 is equal to positive 1. Both of my solutions work. So I have x is equal to 1/2 and x is equal to negative 1. So what happens if maybe we can't factor? Is there another method to solve? So another method is solving quadratic equations by the square root property. So it says quadratic equations of the form u squared equals d, where u is an algebraic expression and d is a non-zero real number, can be solved by the square root property. Square root property is if you have something squared, you can undo a squared by taking a square root. So it says if u is an algebraic expression and d is a non-zero real number, then u squared equals d has exactly two solutions. U is equal to the square root of d, or u is equal to the opposite of the square root of d. So if you have a u squared was equal to d, to get rid of that squared, you're just taking the square root. But remember, when you're looking for a number times itself, you have the positive version or you have the negative version. Very similar to those absolute values. When we split them into our two problems, we had one as the positive and one as the negative. So it says equivalently, if u squared is equal to d, then u is equal to plus or minus the square root of d. Let's try one. So solve the square root property. 3x squared minus 21 is equal to 0. So what they're telling us is we can isolate the x squared. So what would I do first? I'd get rid of that minus 21. I would do that by adding 21. We'd have 3x squared is equal to 21. Get rid of the 3. Divide by 3. We'd have x squared is equal to 7. Well, how do I get x all by itself? Undo the squared by taking a square root. What I do to one side, I do to the other, and we can say that x is equal to the positive or negative version of the square root of 7. Or we can write it out as our solution set, square root of 7 and square root of negative 7. Another method for completing the for solving our quadratic equations is using what's called completing the square. You may or may not remember this from Algebra 2. It says if x squared plus bx is a binomial, then adding b divided by 2 squared, which is the square of half the coefficient of x, a perfect square trinomial will result. That is, we would have x squared plus bx plus b divided by 2 squared would equal x plus b divided by 2 squared. If you remember back to, we had, let's say I had something like an x plus 2 that was squared. We were able to say this was an x squared plus a 4x plus a 4. We had that square, the double, and then the square again. Well, that's all that this is saying here is this is a square. And then this would end up being doubled whatever b divided by 2 was. Whatever b divided by 2, if I double that, meaning I times by 2, the times by 2 and the divide by 2 cancel, and that's where we just end up with that b. So we have a square, we have the double, and then this piece would also be a square. So the way to kind of complete the square is you're looking to figure out what would we have to add in order to make this a perfect square trinomial. So an example, we have that x plus 2 squared, and then another one would be that x plus 3 squared. That's the x to the third plus a 6x plus 9. Our goal is to make what looks like these pieces here. So if I had an x plus 4 squared, I'd have, sorry, this is not a third power. I got carried away with my 3. That's the second power. That would be an x squared plus we'd have an 8x plus a 16. You're trying to figure out if you were given something that you can kind of complete the square. If I add a 4 into this binomial I would have had, or I add a 9 to this binomial I might have started with, or I add a 16 to this binomial I would have started with, that's what it means to complete the square. Finding a way to make it a perfect square trinomial. Let's try one. Maybe it'll make sense as we look at it. So in this case, this says that we have an x squared plus a 4x minus 1. So what they want us to do is go about completing the square. And they tell us to do that by taking the b value, dividing it by 2, and then squaring it. So I want to first get it so all I have is a binomial. In order to get just my binomial, I need to move over that subtract 1, and I'm going to do that by adding 1. So now I'm left with an x squared plus a 4x is equal to positive 1. Now they tell me to take the b value, divide by 2, and square it. My b value is 4. If I divide that by 2 and I square that, 4 divided by 2 is 2. 2 squared gives us 4. If I were to add 4 right here, I can now turn this now trinomial into a binomial that would be squared. That would end up giving me an x plus 2 that would have ended up being squared. Now, I can't just randomly add in 4 to one side of the equal sign without doing what? I need to add 4 to the other side, which means all of this is equal to a 5 now. And now I can use that square root property to solve it down. If I wanted to get x all by itself, well, I need to get rid of that squared next. I undo a squared by taking a square root. That's going to leave us with x plus 2, because remember, a square root and a squared cancel each other out. That's going to equal a square root of 5. And then from there, I want to get x all by itself. I'm going to subtract 2. But the way we're going to have this written out is we are going to say that this is x is equal to, not just that was a square root of 5, but what happens when I take the square root? That would have to be a positive or negative square root of 5, which means my final answer has a negative 2 that's going to combine in there a square root of 5. This is going to take a little bit of practice to complete the square if you have never done this before. If you have done it before, it just might dust off that little brain cell that's inside of your head and figure out how to redo that.